let's go with it. So to get the equation of a plane, we need a normal vector to the plane, and they called this vector n, and we're right, vector n has components a, b, c. And then we need a point p sub 0. We need a point in the plane. And this is p sub 0, which is x sub 0, y sub 0, z sub 0. And in the book, what they do is they get the position vector that has terminal point p sub 0. So I'll just say then vector r sub 0, which would be p sub 0 minus the point, the origin, would be vector with x sub 0, y sub 0, z sub 0. This vector is the position vector that has terminal point p sub 0. So I'll write that. It's a position vector with terminal point p sub 0. Another point in the plane would be p equals x, y, z. So write that. Another point in the plane is P, which is point x, y, z, and we'll let vector r be the position vector with terminal point P. Then, if I do the dot product with vector n with vector r minus vector r sub 0, then that vector r minus vector r sub 0 would be a vector in the plane. That dot product is the number 0. And they did a little bit of arithmetic. Dot product is distributive, so I can do vector n dotted with vector r minus vector n dotted with vector r sub 0 would be 0. Vector n dotted with vector r equals, I'm just adding the dot product of vector n with vector r sub 0 to the other side. So here's the equation of the plane, kind of in 3 different forms. They're all the same, but if you want to think of that as 3 different forms. Now, I could do what I did a little bit ago and carry out the dot product, and I can get this. If we carry out the computation, I end up with, well, vector n was ABC dotted with vector r minus vector r sub 0 is going to be x minus x sub 0, y minus y sub 0, z minus z sub 0, and that dot product would be 0. Now they went ahead and they wrote it the way I wrote it a little bit ago. A times x minus x sub 0 plus b times y minus y sub 0 plus c times z minus z sub 0 equals 0. So you get this. This is the scalar equation of a plane. scalar equation of a plane.